This week, I'm going to take some time to give you some statistics and facts about different planets of our solar system. So here are, you could see just beside me here, you have the information we're going to talk about today. So let's see what we will learn or at least confirm today. So our first planet is Mercury. So Mercury is the closest planet to our solar system, and let's see what we can learn about it. So Mercury is a 0.39 astronomical unit. So here, all the numbers we're going to talk about today will be related to Earth. So one astronomical unit called astronomical unit is an orbital radius or an average orbital radius of 150 million kilometers. So this will be our reference point right here. So let's see. So we have Mercury that is about 40% 40% of the orbital radius than Earth. It is so close to the sun that it has no atmosphere. The solar wind has been pushing a lot of those atoms and molecules that were there, and they no longer have an atmosphere. The diameter is 4,800, almost 4,900 kilometers. That means that it's also about 40% of the diameter of the Earth. So it's a much smaller planet, and therefore there's a much smaller gravity. And you can see that it's much lighter as well from the information we have. We know that the average temperature is 179 degrees, so that means that it's very hot. Keeping in mind that when the surface is facing the sun, it's very, very hot. When the face away from the sun is very, very cold because there's no atmosphere protecting or keeping the heat together. For the rotation, it takes about 58 days or 58 Earth days to do a full rotation. So here the time would appear to move so much more slowly. And the revolution here, it takes about 88 days for Mercury to go around the sun. It has no moon, and from what I know, there's a tiny little magnetism on the planet. It's about 1% the magnetism we would have on Earth. So that is our first planet today. If we want to learn more about Venus, let's see what are its stats and facts here. So with respect to Venus, let's see if I can move this one this way. So Venus is much closer to the sun. So it's about 70% the distance. So it's 0.72 astronomical units closer to the sun. We have a diameter of about 12,000 kilometers. So it's very, very close to what our planet here is. So the diameter of Venus is about 95% the diameter of Earth. With respect to the temperature, it is the warmest planet on our solar system. And the reason for that is, yes, when it's facing the sun, it's warmer. The other side is cooler. However, there's an atmosphere there made with plenty of carbon dioxide. You also have sulfur in the atmosphere, creating sulfuric acid going on all the time. So what's happening? We end up with a temperature that is high. It's like a greenhouse effect there year-round all the time. And I was listening to an astronomer this week, and he was saying that the atmosphere is much thicker than ours. So all the wind that is going on Venus is creating erosion, and that's why Venus tends to be an even surface, which I did not know. With respect to the rotation, it takes about 240 Earth days to do rotation, so very, very slow here again. And the revolution, so the time it takes for Venus to go around the sun, is about 225 Earth days. So the years are much shorter. There are no moons for Venus. I also learned that on Venus, there's no magnetic field. However, it's so close to the sun that it appears to have a weak magnetic field through the induction of the magnetic field of the sun. And that is quite interesting. Very good. So we're going to our third planet on our solar system, which is Earth. What do we know about this planet? So let's see. The average radius is 1 astronomical unit at 150 million kilometers. The diameter is 12,760 kilometers. That's an average. Keeping in mind that if you have, for example, Earth like this and Earth is rotating, that means that the speed at the equator is much faster. So Earth is not a perfect sphere. It is, you think of a sphere that is flattened. So the radius at the poles are much thinner, and at the equator, they're much larger. So that's interesting. So here we're using Earth as a baseline. So the diameter of Earth is 1. The mass of Earth is 1. We have an average temperature of 17 degrees. Now we have greenhouse gases in our atmosphere, which is important. That keeps our average temperature above 0. And that's how we can have liquid water and vapor, as well as ice, which allows life to happen. It takes about 365.25 years to go, days, to go around the sun. And that's why every 4 years we have a leap year. Earth has 1 moon, and the atmosphere on Earth is 80% or so of nitrogen. We have a lot of oxygen, allowing life to be the way it is right now. And indeed, we have a magnetic field protecting us from the solar wind from the sun, which is exciting. So let's see if we can go to our third planet. Our third planet is Mars, and let's see what we can learn about it. So Mars, it has a radius of 1.5 astronomical unit, and has a radius, has a diameter of 600 of 6,800 kilometers. So that means that size-wise, it's about half the diameter of Earth, so much smaller. That means that gravity is much smaller, and because there's less gravity, the atmosphere is thinner, so less energy to keep the atmosphere there. Now, interestingly enough, we have an average temperature of negative 63 degrees. So during the daytime, it is warmer. During the nighttime, it's colder, but that is an average right here. So if we are thinking as humans to go on Mars, we have to keep that in mind. With respect to the length of day, it takes about a day, same day length as us. The revolution takes about 2 years to go around the sun. There are two main moons around Mars, and we have Phobos and Deimos. With respect to the atmosphere, we have carbon dioxide, we have nitrogen, and some argon as well. There is also a small magnetic field that is there. No, there's an X. I think there's no magnetic field on Mars, which is interesting. So that means that the interior working of Mars is way different than Earth. Let's go to our next planet. Now here we have Jupiter, and Jupiter has a magnetic field. That's why we can see through the telescope and space telescope those northern lights right here. So let's see what we can learn about it. Jupiter is interesting. So we are 5 times further from the sun than Earth, with 5.2 astronomical units. We have a diameter of about 143,000 kilometers. So that means that if you take Jupiter like this, you could line up about 11 little Earth to make the diameter of Jupiter. So Jupiter is our biggest planet in the solar system. We also have an average temperature of negative 150. So here we're going away from the sun. It is much colder indeed. But an interesting fact about Jupiter is that the rotation time, the time it takes for rotation, is 0.41 Earth day. So that means that we have 10.2, 10.3 hours for full rotation. Think about that. It's a humongous planet and it's turning twice as fast, more than twice as fast as our Earth. And the consequence of that is that we have so much activity in the atmosphere here of Jupiter. So here we have it's a gaseous planet. So here it's spinning, but it's spinning so fast that it's creating all these storms all the time. I know that Jupiter has this red eye here. It's been, a trademark of Jupiter. It's been there for more than 400 years because when we invented the telescope 400 years ago, we could see this spot right here. But from what I've learned, the spot is getting smaller and smaller as we are going along. Something interesting as well, it takes about 12 years to go around the sun with respect to its revolution. It has 4 big moons, which are about the size of the moon, a little bit bigger. So these are the 4 biggest ones. But since So 61 is the number I had from the early 2000, but there are now 95 recognized moon around Jupiter. It's quite good. Now, interesting with respect to the composition of the atmosphere, it's mostly hydrogen and helium. There's also methane, ammonia, and some water vapor. And that's what's creating all these nice little swirls on its surface. And there is a magnetic field for Jupiter. So this is fun information. With respect to Saturn, when you think of Saturn, we know that it has its rings and we recognize it very easily. But what are the stats about it? For Saturn, we have that the orbital radius is 9.5 astronomical units. So it's about almost 10 times as far to the sun than Earth. With respect to its diameter of about 120,000 kilometers, it's 9.5 the size of Earth. So if you were to take Saturn, you could put 9.5 little Earth to make its whole diameter. So here Saturn is a huge planet. With respect to its rotation, similar to what we have at Jupiter, it's spinning at so the length of the day is 0.45 days. So it takes 10.7 hours to do a full rotation. Knowing that the radius is 60,000 kilometers, there's a lot of speed happening right there. And if you look at its surface, I don't know if we have, let's see if I can find some pictures that could show us some of the swirl on Saturn. There we go. So here's an example of how atmosphere is changing. It's not as much as what we have on Jupiter, but you could see here on the atmospheric line, lots of good things are going on its surface. As we are improving our tech, I'm sure we'll have more details in the years and decades to come. Perfect. Interestingly enough, it takes about 10,000 or 11,000 days to go around the sun, so it's a long year. And with respect to the moon, there are now 146 recognized moons around Saturn. Many of those are smaller objects that are within the rings. The one big moon on Saturn is Titan. It's quite big. It's almost twice as, the diameter is almost twice as much as our own moon, and it has a little atmosphere with nitrogen and a few other things. Titan is an amazing moon with a lot of information and a lot of things to talk about. Saturn is mostly helium and hydrogen, and it has magnetism. So Saturn, an amazing, amazing planet. Let's see if we can look at Uranus. So here's Uranus. We have two pictures here. It shows that Uranus is a planet that is spinning quite a bit. We also have those lines here showing how fast it goes. We know that in the atmosphere, things are going on. We also have clouds that are happening right here. Let's see what we can learn from it. So here, Uranus is 19 astronomical units from the sun, and its diameter of 51,000 kilometers is about 4 times as big as Earth. So if you were to take Uranus, you can put 4 little Earth for its diameter. Interestingly enough, the axis of rotation is at 97 degrees. So as it goes around the sun, it is almost like a rolling ball. It's not a perfect rolling because the axis of rotation is 97 degrees, but it is a bit messy here. The average temperature is 215 here. It's a bit warmer than Neptune here, and the reason is that there's a face that almost always facing the sun, warming up that area. It takes about 17 hours to do a full rotation, so as you can see, the days are quite short for a big planet. Lots of things are going on in the atmosphere. We have 28 recognized moons here, and the composition is helium and hydrogen, but there's also some methane in a bit higher quantity than we have for Saturn. And this methane in the atmosphere gives us that blue color. The reason why it's blue is that the methane absorbs the red wavelengths and more blue is coming towards us. With respect to the magnetism of this planet, it appears to be very irregular. I don't know much more about this, and if you have any questions, I'd be more than happy to answer that question for you. And so that's what we know about Uranus. The last one we have is Neptune. Neptune is the furthest, let's try again. Neptune is the furthest planet from the Sun in our solar system. It is one of those blue ice giant here. It has a blue color because it's made of helium and hydrogen, or hydrogen and helium, but it also contains methane, and methane absorbs some of the red wavelengths, and more blue is coming to us. So let's see if we can learn more stats about Neptune. Neptune is at 30 astronomical units. So that means that the distance between the Sun and Neptune is 30 times the distance from the Sun to our Earth, furthest planet. We have a diameter of about 50,000 kilometers, so it's almost 4 times the diameter of Earth. So if you were to take Neptune here, you could put 4 little Earth to make a diameter. So a huge planet. We have an average temperature of negative 235, so this is the furthest planet in our solar system. It's cold all the time. With respect to rotation, it's 0.67, so it means that it will take about 16 or 17 hours to do a rotation. So here again, we have a very fast spinning planet. That means that a lot of things are going on in the atmosphere, and but can we know more about it? Certainly, but we haven't been close to Neptune in a long time. Therefore, we need to go and send a new satellite, a new probe, to get to learn more about it. With respect to how long it takes for Neptune to go around the Sun, the year is 165 Earth year. So it takes a long time. Keep in mind that the radius is so big. It happens. With respect to its moon, from what we know, there are 16 recognized moon there. I mentioned the composition already, and with respect to magnetism, there is magnetism from what we know on Neptune. But here again, something we need to study a little bit more, I have no doubt. So this brings us to the end of this video with respect to stats and facts about the planet. I know that last week I did a video on showing different pictures and what I know and what I like about the solar system. And I'm going to put a link here in a moment with the information. What's interesting about the solar system is that these are the closest planets to Earth. But it's very hard to get information because planets don't create their own energy. So it's easier to learn from a star that is billions of light years away compared to our planets, because the planets are reflecting light from our sun and not producing their own energy. So that is one of the drawbacks for this. But hey, the more we're going to evolve, the more we're going to send probe into space, the more we are curious about our solar system, the more we'll get to explore and know better. On this, here is a link to a video I did on the planets with specific pictures. You'll see it's amazing, and I'll see you there for more information on planets.